Hi, my name is Doug Ashlock, and today I'm going to be talking about the video scenario number 5 for Aviation 430. And the overall scenario is you've gotten your multi-engine rating, you've got the checkout at your flying club, and now you actually want to take a trip with your new rating. So we're going to go over some of the things that you want to consider when you're making a trip like this. Okay, so the scenario is after getting a checkout in the Flying Club's twin, you have minimal twin time and virtually no time in this type. You are taking a trip on a nice summer day to an area with rolling hills and various field elevations. Okay, on the ground, the planning is going to be very important, and there's some aspects that we want to consider. So number one, where are you going and how far is it? Things to consider are you going to make it in one tank of gas, so to speak? Do you need to stop for fuel? If you don't stop for fuel, will you be cutting it really close? Does it allow for inopportune things to happen, such as diverting around weather that was unscheduled or unanticipated? And when you land, are you going to be at an airport that you're familiar with? Is it an unfamiliar airport? If you're going to stop for fuel, is there going to be a suitable airport along your route that will accommodate the aircraft you're flying? You know, going into a 2,000 foot, 30 foot wide runway may be doable, but it might be really challenging depending on how hot that summer day is and your familiarity with going into a small airport like that. So those are some of the things you might want to consider. All right, what lies along your route? Are you going over mountains? Are you going over large bodies of water? Are you going to be going over a bigger city? Anything along those lines? What is on your route? Is there antennas? Is there water towers? Things that you can use as visual checkpoints. And all of this will help you determine the overall route of flight along with your route of flight, so to speak, because you want to make sure that if you're going to be flying over mountains, that do you have mountain currency? Does your airplane provide you with the capability to go over the mountain? Now, we'll get into this a little bit more later on, but the single engine service ceiling of your aircraft will probably be too low to accommodate a single engine flyover, and if you do lose an engine over a mountain, it's your best rate of descent, and you're not going to be able to maintain altitude unless you have turbocharged aircraft, but even still, it's not a guarantee. Okay, what is your destination field elevation versus field elevations along the way? Now, if you're going from point A to point B, and the field elevations are, somewhat close to each other, but there's hills in the way, in the middle. And, if you put down in one of those airports along the way, are you going to be able to take off again? So you'll need to go over your performance charts for that altitude and determine if those airports have enough runway. And we'll look at that and see what that looks like here in a second. So any considerations for takeoff performance, weight and balance, density, altitude, it kind of plays into that a little bit from the previous point, but are you going to be at max takeoff weight? Are you going to be at your center of gravity forward limit or aft limit, anything like that? And are you going to have any issues with takeoff performance that may make you determine to not go or decide to postpone until it gets cooler? Things like that are things you want to consider before you even leave the ground in the planning process. And then you have any special procedures for the airport or your route of flight. Something like the Grand Canyon. If you're going to be flying over something like that, there are special rules you want to get familiar with before you even attempt to go. And even if you are familiar with it, you may run into aspects that are not the norm with flying. Okay, so when we're planning this flight, we're looking at the takeoff and landing distance charts for the PA-23. It's a Piper Apache for the aircraft that I fly. And we're going to determine our takeoff weight. The airport elevation I'm at is fairly close to sea level, so I use about a dot high over sea level because this is 2,000, 1,500. So I'm right at about that first line. And I'm usually in the 3,800 pound range, sometimes a little more because my aircraft has an STC that allows it to have 4,000 pounds gross weight. However, we rarely get it into that range. So I figure it at 3,800 so I don't have to extrapolate data. All right, so takeoff distance in feet at 500 feet. Now that's assuming a standard altitude and the density altitude is 0. So at 500 feet MSL, field elevation, I can expect just a little over 1,200 feet, somewhere in the neighborhood of 1,300 feet for a takeoff. Now, I'm not going to take off if I can't take off, have a problem, recognize that problem, and then come to a stop. So I'm going to calculate my landing distance also. So again, 500 feet elevation, max weight. It's telling me somewhere in the neighborhood of 760 feet to stop. My airplane does have an STC for dual brake calipers, and it stops very well. I would feel fairly confident in that number. And so I would add this number to this number, but I don't want to just put these two numbers together, because once I hit this takeoff point, and if I have a problem right then, the reaction time may be a little bit of a factor. So factoring in about a 3-second delay, for whatever reason I don't recognize it right away or anything along those lines, that 3-second delay will equate to roughly 300 feet, give or take, but it's a good ballpark number. So the 1,300 here, the 750, 770 here, plus the 300, give or take, puts me at about 2,200 feet off the chart. And I like to have a safety margin as well, so I would call that 2,500 feet of runway available to me before I even attempt to take off or land at an airport if I can't get those numbers. And then again, those numbers just get bigger whenever the density altitude gets warmer. All right, rate of climb, multi-engine versus single engine. I'm at the highest weight category again, and this is 8, 6, 4, 2, so I'm just right above the main line. So I'm looking at roughly 1,200 feet per minute climb rate at my airport elevation with both engines operative, and I'm in proper configuration and I maintain that proper configuration. As I start to climb up, I'm going to hit a service ceiling of about 1,600 or 16,000 rather, and that's going to be my multi-engine service ceiling. My absolute ceiling is about 18,000. If I lose an engine, one engine inoperative, that climb rate goes from a little over 1,200 to right at about 200, just a little under actually, about 180. And this weight, as I go up, I hit that single engine service ceiling at about 4,000 feet, and then right at about 5,500 feet, I should be at the absolute ceiling, 0 feet per minute climb rate. When I'm planning my distances, my routes, how long is it going to take me to get there, I'm looking at my gallons per hour on the consumption, as well as the manifold pressure and the sea level that I'm going to be at. So once I've got this manifold pressure and RPM setting set, I can expect a ballpark figure of fuel consumption, and this is per engine. So I always range right here at about 8. 8's a good number, and I either fall on the either side. I typically try to plan on the extra side. I may put my figures at the 7 gallons per hour table, but I'll plan for 8 because it's always better to plan for using more fuel than you actually do, because of how precise these numbers are determined by a test pilot with a brand new airplane, that whole spiel. If I use these numbers but plan for these, I might actually get something to what I actually planned for. And so far, that's actually worked out very well for me. Okay, and we're also gonna have this range. So I'm gonna be able to determine how far I'm going to be able to go. And it's right at about 1,000 miles, anywhere between 1,000 to 1,100 miles. If I'm using my peak power settings for best economy, and I lean the mixtures for best economy, and that allows me to really get on it. And again, trimmed out aircraft, everything's spot on. Now, time in the air is a little bit different, but that would give me a couple of hours. With true airspeed, this is what I'm going to use to determine how quickly I'm going to be going through that air, so I can determine a ground speed. And again, about 65% power, roughly 8,000 feet. It's, it's about 165 miles per hour. All right, other things that you consider whenever you're planning your flight is the airport you're going to be flying into. Again, is it familiar? Is it not? Do they have things like this where they have land and hold short operations in effect? Are you going to be able to accept that clearance? Be prepared to accept or deny a clearance like that. If you deny it, which is your pilot and command privilege, be prepared to have to pull off and do a 180 in the pattern, or something like that, to allow the spacing for them to get that airport operation going. And that goes into the planning process. How long are you intending on being in the air? Are you going to get to the airport with just reserves? And if that's the case, how long can you truly just spin your props in the air before you really need to get on the ground? Most airports will do a pretty good job of getting you down, but there are accidents that do have points where things like this have happened, where the pilot says, hey, we're kind of low on fuel, but they didn't realize, the airport didn't realize that the pilot meant to say critical fuel. We are about to run out. We need to get on the ground now. And it was in a situation like this, busy airport, and also the airspace at the time was also very crowded, things like that. So there's also considerations with taxiing and being familiar with where you're going. And if you don't know where you're going, ask for a progressive taxi. Again, you're getting a service provided to you by ATC. Even if they don't like it, that's on them. You can still ask for it and they'll still provide it. What would the flight look like? Paint that mental picture of the terrain. Are you going from a 500-foot field elevation to a 2,500 foot? Well, depending on your altitude, if you're really, really high up, you may not notice it right away, but if you choose an altitude of, say, 4,500 feet, that 4,500 feet initially is high up in the air, and then when you get to that 2,500 foot elevation, you're only 1,000 feet above the traffic pattern now. So that's just something to consider. You're going to notice that terrain coming up from underneath you, and that's something you should plan for appropriately. You wouldn't want to fly in at the traffic pattern altitude unless that's your plan. I particularly like to go over the airport if it's an untowered airport, and get a view for the airport and look at the SOG and see if there's any traffic in the area. It allows me to be established in that environment for a little longer so I can get a better feel for it. And then use your Google Maps. Google Maps is a really good resource that a lot of time goes unused. If you're going to a new airport, you've never seen it before, go to Google Maps. They've got a picture of it. You zoom in on it and you get a picture of what it's going to look like. What color is the runway, so you know what to look for at the distance. What kind of buildings are around it, where the fuel farm is, where the FBO is. All these things you can look at on this Google map and see the actual picture of it, not just a taxi diagram. You can actually see the airport itself. You can also use the Google Maps feature to scan along your route of flight to determine things that you might use as visual waypoints, such as, a rock quarry, something that'll stand out. It's a green forest with big white rocks in the middle of it. That might stand out, and you could use that as a visual reference. Things like that you can really use to help your planning process. What frequencies can be expected? Now again, nothing's going to tell you for sure this is what frequency you're going to get. But again, having that plan can make things a little easier. I'm going to do this, and I plan on doing this, this, and then this. And if all goes swimmingly, you'll follow that plan and it'll really reduce your workload. Again, it's a plan to start with. Your plan will change, probably. That's fine. Just having somewhere to start will allow you to know what's going to happen next. If you know you're going to contact Houston Center next, contact Houston Center next. Fort Worth Center, you know that there's going to be some sort of frequency handoff somewhere around this part of my map, and I can expect a frequency change there. And if you're familiar with the route, you might even know what frequency it will probably be. So even though you're in VMC, are you going to be flying VFR or IFR? And there's benefits to both. The workload for VFR is typically a little bit less. However, the IFR can be very simplistic. They can get you, turn this heading, go this way, and they'll help you with traffic scanning. I know you're VMC, so you're still responsible for traffic scanning. However, that does help to have ATC have their radar eyes on you if that service is available with where you're operating. And then how much, if any, technology will you use? My plane doesn't have too much in the way of technology. I have a Garmin 430 and a Bendix King 155. I have an inoperative ADF, and I have a Stratus Apiro transponder. As far as avionics go, that's it. I don't have an autopilot. I don't have a storm scope. I don't have a lot in the way of technology in this aircraft. It's a really old airplane. However, I know that the analog gauges that it has are maintained appropriately. I know that it has its pitot-static check, its altimeter check. I know it has the AVIA acronym of inspections. And I know that to meet that requirement, it's required to have those inspections. And so I'm comfortable with my mechanics and how they present that in the logbooks, and I look at it almost regularly so that I know that my aircraft is in compliance with these regulations. All right, considerations for the flight itself. Even though you're still close to your training, your experience will be limited. So again, you're used to your engines always failing. Every flight, your engines are going to fail because that's your training environment. However, you have training experience. You don't have real world experience. Although training is important and recency of experience is helpful, having that real world experience is helpful also. Time and type reduces your familiarity of procedures, but you completed a checkout with the club instructor. So again, this balances a little bit. I'd say more on the side of the familiarity. You're not as familiar with this airplane, but the check instructor did deem you capable of flying this aircraft. So there's something in that instructor's mind that says you can fly this plane. Now again, follow your procedures, use your checklists, don't leave things to chance, and remember, fly the airplane. Things to consider are how similar does this airplane fly to the one that you're used to flying, and are the procedures and or airspeeds similar? You have a Piper Apache and you have a Piper Seneca. Their airspeeds are a little bit different, but they're not too far off. You could use both airspeeds in and of each other with the other aircraft and still safely fly that airplane. Their VMCs are very similar, their blue lines are very similar, so you're looking at a very similar aircraft. The flight characteristics are a little bit different because the Seneca has counter-rotating propellers, so it removes that aspect of a critical engine, so to speak, but that airplane flies very similarly to the Piper Apache. The Piper Apache that I do fly has a critical engine, and it's extra critical because it doesn't have redundant systems such as a hydraulic pump. If you lose the left engine, not only are you dealing with the typical light twin problems of a critical engine, you're also dealing with using a hand pump to put down your gear and flaps, which if you're in an IFR environment, that's a big problem. Well, it's not really a problem. However, it is a bigger consideration. You need to know ahead of time to start putting your gear down because you're going to be pumping it down. It's not a flick of a switch anymore. Is a safety pilot a good idea? Are you going to bring somebody who has more time and type, another club member or your checkout instructor? Are they coming on this flight with you also? Is it a flight just for fun? Are you doing it to go see a wedding? Whatever the case may be, is a safety pilot appropriate? And again, they're not just for IFR practice. It's a safety pilot. They're there to help make the flight safer. how much familiarity do you have with the route and the area? Again, we talked about that a little earlier, so I won't go too much into it again, but being in a familiar environment might help ease that transition into an unfamiliar airplane instead of being in an unfamiliar plane, unfamiliar airport, unfamiliar area, and everybody has a weird accent because you're in a different state now. So all these things can add up to a really uncomfortable situation and make a really benign situation into something more than it really should have been. All right, special considerations for multi-engines. Will VMC be an issue for this flight, or will the plane stall first? So if you enter the state of VMC versus will you stall and then VMC roll, it's really important to know where you're going to be at on this density altitude scale, and are you going to stall first or VMC condition first? Will you be above the single engine service ceiling? We looked at that performance chart. So if yes, will the terrain along the route of flight allow for a descent to the single engine service ceiling? If the terrain is only coming up to 3,000, but it's rolling hills, but your single engine service ceiling is 5,500, I think that would be appropriate to go down to that level and hold altitude right there. If your terrain along route is 8,000 and you're at 12,000, you lose an engine, your single engine service ceiling's about 2,500 feet below your terrain elevation, start looking for a spot immediately to put it down and start that process of maintaining blue line in the one engine inoperative configuration. Zero thrust versus a full feather. So zero thrust configuration is really useful in a training environment because it requires the student to still fly with a simulated engine out, but it doesn't require the shutdown or the feathering of the propeller, so it reduces the amount of wear and tear on that propeller and the propeller hub as well. Versus a full feather, there's something psychological about seeing that engine truly stop and feather versus, it's still out there on the wing spinning and the pilot can see it and it's a training environment, and if you need to, you can still push it forward. It's kind of like a double down on the stakes type of environment. On that feeling, so it can provide another sense of stress on that. So if you have a single engine approach to landing, again, just remember as you bring that power back, you're going to need less rudder input. Your turns into your good engine are going to be a little easier. You can have more bank into that good engine versus the opposite because of that rudder authority. You're going into the good engine with that extra authority. Are you going to execute a go around? Well, can you exit go around is one of the things you should ask. If you're going to be at 8,000 feet and you lose an engine going around, you're not going to do that because you're 2,500 feet above your single engine service ceiling, so you're going to land, and going around won't be an option. So make sure you make that single engine approach good, and it's okay to be a little long, it's okay to overrun the runway, it's okay to put it in the grass, whatever you need to do so that you can walk away. Sacrifice the plane, we have insurance, it's fine. All right, if it's deemed safe to do a go around, how do you do it? Well, the first thing you want to do is reduce the drag. So you want to put your flaps up. In my aircraft, the POH says to just put all the flaps up and let the airspeed come up. Our chief pilot has told us that that is not what he desires, and so the school operating procedure is half flaps initially, build the airspeed, then go to zero flaps. Once you have a positive rate of climb, then gear up, or at least leveled off. You don't want to pull the gear up while you're still having that downward rate of descent, because as you go down, you may bounce off of that runway before you start to go back up, and if you don't have your gear down, then you've crash landed, and having the gear down would allow you to use either that momentum or at least abort the go around into a forced landing at that point. All right, so when we're operating single engine, we have a considerable amount of drag on the inoperative engine and thrust on the operative engine, known as asymmetrical drag, asymmetrical thrust. You're going to use the rudder to balance that force. So in this case, the right engine's operative, the left engine's inoperative. Right rudder force is required to help balance that because this right engine wants to turn the airplane to the left. So we want to use this right rudder input to help bring it back. Now, if we truly did line that up to where this completely balanced this, the airplane would be in a side slip to the left. So what we want to do is bank into the good engine, no more than 5 degrees, and use that rudder input to counter this thrust. And because of that, that turn will help counter that side slip to the left. And that configuration is known as zero side slip. The best way to get rid of this drag, or significantly reduce it, I should say, is to feather that engine as soon as practical. And that'll help really reduce that workload on your leg, and you don't want to be pushing on that rudder for too long, because the manufacturers are allowed to have up to a certification of 150 pounds of pressure. It's like holding up a person on your leg, and the longer you do that, the more fatigued your leg will get, and you'll have you might have variances in your rudder input the more it gets tired, and you may encounter muscle failure also, and you'd no longer be able to maintain directional control, and that's a considerable problem. All right, so these are the references that I used: the Airplane Flying Handbook, Pilot's Handbook of Aeronautical Knowledge, and the Piper Apache Owner's Handbook. I really appreciate you listening to my video, and I look forward to any future assignments. Thank you. Have a good day.